Hi astronomy students, it's Mrs. Thompson here, and this week we're going to be looking at coordinate systems and how Earth's tilt results in its seasons. So the coordinate systems we're going to be looking at will be for terrestrial and celestial coordinates. I'm going to show you some of the simulations you're going to observe and then help you navigate through that on the website. The objectives for this lesson are to be able to describe the terrestrial coordinate system used for mapping geographic locations here on Earth, to describe the celestial coordinate system that's used for mapping astronomical objects, and then, so notice that the terrestrial system is different from the celestial system, and that this is here on Earth and this is for objects in the sky. We're then going to identify the most used great circles on Earth. If you're confused by what a great circle is, then you should look that up, and it is one of your vocab words for this week. Lastly, we'll explain how Earth's tilt produces seasons, not tidal, tilt. Okay. So, you need headphones to be able to listen to me speaking. You need a pen or pencil to write with. The link to the computer simulation is provided in Google Classroom, and then a copy of the worksheet to label areas on that sheet. If you don't have a printer and you aren't able to access the worksheet just yet because you're in Cohort B, then you can simply do a row and column system on a piece of paper and just copy down the numbers that appear on the worksheet. For your Earth, you can just make a circle and then draw the lines across and label them where appropriate. So first we have terrestrial coordinates. These are measured in units of degrees. We have latitude, and latitude is going to be running across this way. And so these are horizontal lines. They range from 90 degrees north to 90 degrees south, with 0 degrees in the middle being the equator. Longitude runs the other way. So longitude runs from top to bottom. And so these are vertical lines that appear, and they range from 180 degrees east to west. So 0 degrees is here. This is where we have our prime meridian. The celestial coordinate system. So if we look back at terrestrial, this is if we have a flat version of planet Earth, a flat map version. We also have a flat map version of the celestial sphere, or celestial coordinates, but they use different units of measurement. There's declination, which is represented by the lowercase Greek letter for delta. These are horizontal lines. So here we see again, these are the horizontal lines. They're also measured in degrees, and they range from 90 degrees plus 90 degrees to minus 90 degrees, with 0 degrees being the celestial equator. So instead of north and south, we have a plus and a minus, but it's still in degrees, still has the same range for numbers, and still even has a 0 value for halfway through. Right ascension is going to be the vertical line. That's represented by the Greek letter alpha. So the vertical line, right, is running from top to bottom. This is a little bit different because the units of measurement are 0 to 24 hours. So hours is the unit that's used to measure right ascension. Also, when you're here, you're going to be asked about North Star, which is Polaris. That is at about 2.5 degrees, right ascension, and 90 degrees for your declination, plus 90. That's your north celestial pole star. There is not a southern celestial pole star. It's a little bit harder to navigate there. This is your celestial sphere. So as we see around here, this is the celestial sphere. This is Earth. You're going to notice that Earth is not tilted here. So this would be your North Pole. Your celestial North Pole would be above it. So this is your celestial North Pole. Again, so what's going to be representative of that celestial North Pole, that one pole star, is Polaris, that's located there. So this is your South Pole. Woo. I'm trying to do this with my mouth. so it's a little bit messy. And then this is your, I'm going to try it with my finger and see if it's any better, your south celestial pole. Much better. There's no single star there though. You have to use a couple different constellations to find that point. And then this white line here is your ecliptic. So that's your ecliptic. And then this green line here is your equator. So this is your equator, okay? So this is your equator. And then when you have your sun, the ecliptic is the path the sun takes around the earth in a year. When the ecliptic, when the sun's path is right up here, maybe, and here I'm gonna mark that with a different color. So when the sun's path is here and it's in that spot and we're in the northern hemisphere, then that is going to be where the sun is having its most direct rays, will be right here. So that's going to be when we have summer or our longest days. And then when the sun is down here in its path, we are in the northern hemisphere, so that'll be the time the most direct rays are in the southern hemisphere, which means that will be when we are having our winter solstice or longest winter day of the year. So there's another explorer that you'll use, and this is the seasons one, and you'll be able to move this little person in different positions to be able to see where the most direct ray is. So where the person is, that's where your most direct ray of sunlight is at that point in time. You can move the person in different places and you can change the time of year that exists. So here you're going to see that you have your equator is halfway through. So that's your equator. Your Antarctic circle is going to be here. That's one of the commonly used great circles. Your Arctic circle is up here. And then your Tropic of Capricorn is this red line. So the Tropic of Capricorn is here. And then your Tropic of Cancer is this line that's below there. So between those two areas, between here and here, the Tropic of Capricorn and the Tropic of Cancer, that's where the sun will always have its most direct rays. Will be within one of those ranges, between 23.5 degrees north and 23.5 degrees south. And so, let's see, note that the direct rays are at the latitude of 23.5 degrees north on the Tropic of Cancer. So let me just make sure I did that right. Yes, Tropic of Cancer is here. I always get Tropic of Cancer and Capricorn confused. Okay, so you are going to be using the simulator to answer a couple of questions. And then once you're done that, this is going to help you. This is a different way for you to view those light angles that are hitting the Earth. So this is when you would have, this is the sun's altitude's 90 degrees. The observer's latitude is 23.4 degrees north, which is where you're going to have your Tropic of Cancer on the summer solstice. So that's for us in the northern hemisphere in June. And so you will be asked in the box to the right, draw these rays as seen by an observer from the Tropic of Capricorn. So that's going to be if you're at 23.5 degrees south longitude or latitude. Sorry. Okay, so that's that. I'm going to discard those. Then what I want to show you is the actual website that you're going to be using. So in the astronomy labs, we're looking at basic coordinates and seasons. Now I've used this today, so some of these are showing up as a lighter color. You need Adobe Flash to use this simulation. So when you come in here, you're going to, under terrestrial coordinates, open up this. It's going to say click to enable Adobe Flash Player. You have to do this first for the simulations to work. So I'm going to click and allow it to work. This allows you to move, these are different meridians, these are parallels of latitude, so these are examples of great circles too. So then you can see this pathway here for the labs. When I go back here, I can then open up, this is for terrestrial coordinates, this is celestial coordinates, and then this is the seasons. So here's the Flat Map Explorer. These are your terrestrial coordinates. There's different features here that you're going to be able to use. And then when I go back here, I can see the Globe Explorer if I wanted to use this. And the only thing is that you need to know it says click on the globe to change the cursor location. So I could say, okay, now I'm here. Here's my latitude and my longitude. Hold shift, and then click if you want to be able to move the globe around and not just the position of the cursor. Back in basic coordinates and seasons, here's the flat sky map explorer for the celestial, and here you can show different pieces of information that you're going to be needing to look for and label on your sheet. I'm going to go back one more time. I can see the sky map explorer. So here's another version. This is kind of like the Earth one. This is the celestial sphere. I need to shift and hold shift down while clicking, doing the left click, in order to be able to move this. So if I look here, I can remember that this alpha symbol represents ascension, right ascension, and the delta represents declination. I'm going to go back one more time, and then I'm going to see that there is the seasons and ecliptic simulator. So I can look here. This is where I can move my person around. So moving my person around here, this spot is where the most direct sunlight is, where I see this ray coming in, and this is where it's making contact on Earth, is for its most direct ray. And it's cool because I can change any piece of this and it changes the other views too. So it's giving you different perspectives for this really abstract thing that happens. There I can see if here's the sun and there's its most direct ray at that point in time. So these are different dates that you can use to see, okay, on June 21st, where do I have my most direct ray? Okay, so my most direct ray should be at that Tropic of Cancer. Okay, so I can move my person there. So see my person there, and then I can see that my rays are pretty direct, so almost 90 degrees there. I can add labels. I can remove labels. I can also change views. This is an orbit view. This is the celestial sphere view. So here's my celestial sphere view. And I can also add labels and remove labels. And I can have the animation go, and so I can just see how this changes throughout time. And I can watch different pieces that are interesting to me. So I know that's a lot, but this is really fun, and it's a great way for you to really understand how seasons result from Earth's tilt, and also lets you look at how we're mapping the Earth and how we're mapping the sky. Have fun learning!